Hello and welcome back. Today we'll be creating the foundations of a 2D terrain generator that we'll use in future videos to make fun little simulation games and much more. Now, what I've got here is a really simple setup. It's a really simple little project, I should say. It's got some basic land tile assets, basic scenes folder with the main folder and a terrain generator folder. Now none of this is populated other than the main scene, which is what we're currently looking at. It literally has nothing other than a world node, which is just a basic 2D node, and then we have the assets here, which is basically just 4 or 3 squares. Now I'll pull this out a little bit. You can see here these are 48 by 16 and it's just 3 squares along, which means that each square here is 16 by 16. Now you can go make these in Paint, in Sprite, in pretty much anything. I just opened up Sprite and I made the canvas size 48 by 16, separated it into 3, and these are my basic tiles for grass, sand, and water. Now you can go kind of wild with this, but we're going to be sticking with 3 tiles for this video, but in future videos we'll be really expanding upon the tile set and doing a lot more. So for now, let's get the basics handled. Let's just figure out how to start generating terrain. So for the first thing is let's go and create a new scene here. This will be of other node, and we're going to be using a new node introduced into 4.3 stable. Now keep that in mind, this is Godot 4.3 stable, so the most recent release. So we're going to be using the tile map layer. Now if you don't see this and you only see a tile map, that's okay, you can still use the tile map. Just remember you're on an older version, so things may not work entirely the same way. But for what we're going to do here, we're going to use a tile map layer. Now, I'm not going to go into too much depth onto what a tile map layer is. I will kind of explain that as we go in future videos, because we're going to be kind of making a lot of use of it. So let's go and name this the terrain generator. I can't spell the word generator. There we go. Now all this is going to need is to be saved. So let's hit Control S and save. Let's go under Scenes, under the Terrain Generator folder, and click Save. So now we have that saved and we can start modifying it and messing with it. So once you've got that sorted, let's go into the right side here, into the Inspector. Under the Terrain Generator, we're going to hit that empty button and grab a new tile set. I'm going to come down here into the Tile Set button, and we are going to drag across that basic land.png that I created right here, or whichever you created, and it will say here, a little pop-up for yes or no, would you like to automatically create this tiles in the atlas? We're going to write yes, and now it's separated our tiles into these 16 by 16 tiles that they are. So if I select all of these, I can place them all down like so, or I could select individual ones, and now we have our basic tiles. So let's actually get to the fun part of this, the actual coding part. What I'm going to do is I'm going to hit Control S and save. I'm going to create a new script and attach it to the terrain generator. Now I want to give this a class name so I don't forget, and so we can use some of its functionality later, of terrain generator. We're going to remove the process function and we will keep the ready function here. Now, when designing a terrain generator, or pretty much anything kind of like this, when it comes to kind of programmatically placing tiles, one of the first things you want to do is figure out how you want to place them. Now, think of a box, right? Let's go back to the 2D scene here. So we've got this box, this view here, which is whatever our project window is currently set to, which is 1152 by 648. So that's how big this box is. So what we want to do here is basically fill this box out. Now we have an x-axis and a y-axis. Now if you look in the bottom left corner of my screen when I'm hovering over the center here, you'll see in parentheses there 0.0. If I move over to the right, 1.0, 2.0, 3.0. So that's our x-axis. So what about y-axis? Well, we're going to want to go down with this, right? So let's go down. And 2, 3, 4, 5, 6, 7, which means if we go up, that is going to be negative. Same if we go left, negative. So keeping that in mind, that means we want to draw a box, which means we're going to want to go positive in both directions and actually fill this out. Now, that might not make a lot of sense, but what this does tell you is you need a height and a width for the box that you're going to create, right? So let's go back into our script here. Let's use an export var. We're going to call this a terrain underscore width. It's going to be of type integer, and I'm going to just preset this to, let's go 50 to start. Now I'm going to do the same thing for the terrain underscore height. Set it as an integer, and I'm going to set that to 50 as well. Now with the last example, or my explanation, it may not make a lot of sense why I'm only doing 50 by 50. That might seem a bit small, but just kind of go with me here. Next thing we're going to need is, this is a weird one. I don't really know how to name this. So one that will cause problems. There we go. Terrain height, and this will be called the terrain underscore resolution underscore multiplier. Now, this will also be set as a floating point, and I'm going to set this to 10.0 for now. Now, this is a weird one. I don't really know what to name this because resolution multiplier isn't really correct for the name with how we kind of use it, but it's the only real thing that I could think of that would make a little bit of sense. So with those two done, let's just get into generating our terrain, right? Let's go create a new function here, and we will put that resolution multiplier to use in a second as well. So we're going to call this new function generate. I am not able to spell today. Generate underscore terrain with a void return type. Now, all we want to do here is loop over the width and the height and place a tile. That's it. So to do that, we're going to use two for loops, or a nested for loop. We're going to go for x in terrain width. And then we're going to go for y in terrain height. So that's going to basically go right down, right down, right down. And it's going to basically fill out that whole box for us. So now that we've got our box, quote unquote, looping through, we just need to place the tile. So to do that, let's first just get a green window, right? Let's get a green box filled out. So because this is a tile node or a tile map layer node, we have access to the set cell function, set underscore cell, like so, and it'll give you the list of things that it needs. First, so let's go and click on the set cell function here with a control click, and it will tell us here how this actually works. So set cell takes a coordinates value of vector 2i, that's very important, source, an atlas coordinates, and an alternative tile. Sets the tile identifiers for the cell at coordinates. Each tile of the tile set is identified using three parts: the source ID, the atlas coordinates, and the alternative tile. If source ID is set to -1, the cell will be erased. An erased cell gets all its identifiers automatically set to their respective invalid values, namely -1, -1, -1, -1. So that's kind of how this functions, right? So it's just going to place a tile at a specific point, and the tile is going to be what we pass through. So let's do this. We want to set a cell. Where do we want to set that cell first? Well, we want to set it, remember, vector 2i or 2 integer. We want to set it at the x and the y coordinate that we are currently at here. Now, what else does it need? Let's add this. It needs a source ID. So currently it's preset to 1. Let's come down to our tile map here and let's figure out what source this is. You can do this by just hovering over one of your tiles and it'll give you the information you need. So the source is 0. So we want source 0. And now it wants an atlas coordinate, so a coordinate within the atlas down here, which will show us, what we're basically just picking the tile. So you can see here the atlas coord for green is 0, 0. For the sandy color is 1, 0, and for the watercolor it's going to be 2, 0. So let's just go with a vector 2i, and we'll set this to 0, 0 for now. Remember, 0, 0 will be our green tile, or our grass tile. So the last thing it needs is an alternative tile. We don't actually need alternative tiles, so we can just set that to 0, or we can just completely leave it out. Now I'm going to hit Control S and save. Under the ready function here, I'm going to call generate terrain. Now I'm going to hit Control S and save again. I'm going to go under the main menu, or our main scene, onto the world node here. I'm going to use Control Shift A, and I'm going to add a tile generator. And now, if I press play, and I hit select current for the main scene here, you'll see we now have a green box. That's it, we now have a green box. If I hide the terrain generator to make sure that you can kind of see what's going on, there is nothing, but now we have a green box. So generating basic grass at least, or at least a green square, right? That's really good. Let's bump up the terrain width and the terrain height to 100. Now, don't go too wacky with these numbers. If you do usually more than like 800 by 800, it takes a very long time because it's got to loop through basically 800. I think it's 800 squared. I think that's right. I could be wrong. Math is really not my strong suit. Yes, as a programmer, I know how insane that sounds, but math is really not my strong suit. But this is a lot of tiles. So we're generating the terrain. So what about this terrain resolution multiplier? What do we want to do with this? Well, let's first go and get a little bit of UI set up before we continue with this. Let's go and add a new scene. This will be off user interface. Go to the 2D scene here, make sure that this is anchored correctly to the full screen. So anchoring full screen. I'm going to just rename this to UI. I'm going to use Control A and I'm going to add a margin container. I'm going to once again anchor this to the full screen, and then to that margin container I'm going to add a button. I'm going to call this the generate, and now we'll just call it generate terrain like so. That's all it's going to say, and we're going to align this to the bottom, and then we're going to shrink the horizontal alignment to center like so. Now I'm just going to come down to theme overrides, font sizes, and I'm going to change this to, let's go 32. 32 is pretty big. Final thing to do here is the margin container, theme overrides, constants, my normal 12 pixel border or padding for the margin container. Now we're going to go hit Control S and we're going to save this. I'm going to create a new folder under scenes, call it UI, and I'm just going to hit save. Let's go back to the main scene real quick. On the main node here, I'm going to hit Control A and I'm going to add a canvas layer. And then I'm going to, we'll just call this the UI layer, because that's kind of what's going to be going inside the canvas layer. Then I'm going to use Control Shift A and I'm going to add the UI node here. I'm going to hit Control S and save. Now when I press play, what should happen is the button should be centered on our screen. Now it doesn't do anything, of course, because it's just there, it's not hooked up to anything. So let's go and very quickly get that hooked up. So we're going to give the UI a script. And we're not going to need ready or pretty much anything on this. All we actually need to do is left click the button, go to node, base button down for the button down signal, hit connect, and we want to do something inside of this. For now, I'm just going to print generating terrain. Make sure I spelled that correctly. Now I hit play one more time, make sure it works, and as you can see down at the bottom here, it's now quote-unquote generating the terrain, even though it's not doing anything. But this we'll come back to this and we'll put some kind of make use of this in a second. Actually, no, let's do this now because I will get confused otherwise. So what we want to do here is we want an export variable, and we want this for the terrain underscore generator. We'll set this of type terrain generator because we gave it a class, and we'll set it equal to null. Now what I want to do on button down here is call the terrain generator dot generate terrain function. Hit Control S and save. Now what that allows me to do is basically wipe the function or the ready function, and now I can just press play and generate the terrain. Now it's saying non-existent function. Why is it saying that? If you remember, what goes wrong with me consistently is I forget to assign the terrain generator in the layer that it's actually on here. So we need to come down to UI in our main node here, or our main scene, click UI, assign the terrain generator, and try that again. And there you go. It's now generating the green square at a click of a button. Perfect. So now we've got this generating, we're going to want to clear it, right? So one thing when you're generating terrain or basically doing anything like this with a tile map, you want to make sure you're not layering or kind of doing anything odd, you want to make sure you clean out the tile set every time you do something with it. In this case, at least, when you're generating big terrain, you want to clean it out beforehand. So to do that, we're going to write func clean underscore terrain underscore map. Give it a void return type, and all we have to do here is call the tile map data, which is part of the tile map layer, dot clear. Now, every time we generate terrain, we want to make sure we clean the terrain map, so make that no longer happens. And now, although this won't make a difference to what we're currently doing under the generate terrain, it is actually deleting every single tile here and then regenerating all of them. So we've now got a basic cleaning and setting function for tiles, but we're not actually setting any tiles yet, are we? So let's go and actually change that. For that, we're going to need one more export variable inside the terrain generator. Now, this is a weird one. We're going to grab an @export var. I'm going to call this the terrain underscore height underscore map, because that's kind of what this is, a height map of sorts. And this is going to be of type fast noise light. I'm going to set that equal to null, and we'll kind of go over this. Now I'm going to hit Control S and save. I'm going to come over to the inspector, and you can see here that the terrain height map is here, but it's empty. So I'm going to click on it. I'm going to click new fast noise light, and then I'm going to click the fast noise light button. And as you can see here, it literally just generated noise. If I change the frequency here, you can see that it's literally just white noise, TV static, what you'd see. And that's all this is doing, is generating that. Now, based off of the height map here, or basically the white and the black, we are going to be grabbing a number value. So we'll say white is, in this instance, 1, and black is -1. We're going to, of course, want to go much higher than that, and this is kind of the complex part with how fast noise works in Godot, but I'll kind of explain that as we get to it. But we basically just want to grab value based off of how bright or how dark the color is, and then use that to select a tile. And that will start generating actual terrain, islands, lakes, rivers, oceans. And that's really, really fun, and a really kind of programmatic way of doing this without having to get your hands dirty and get in and build the map yourself every single time. Now, there's a lot of settings with this that we can change as well that will make it generate differently every single time. So I'm going to reset the frequency here. Let's push that back in. And now we have our terrain height happening. Let's first create a new function. We're going to call this set underscore up underscore terrain underscore height underscore map, because it's going to need to have a few things randomized on it that we can't do unless we want to go through and change this frequently. This will basically just randomize the terrain every single time we press the button. And the first thing we want to call here is the randomize function. So what does randomize do? Let's Control left click. Randomizes the seed, or the internal state, of the random number generator. The current implementation uses a number based on the device's time. So we're basically just resetting the seed to another random number. And then we're going to do, and kind of go one step further with this, we're going to grab our terrain height map. We're going to use dot, and we're going to grab the seed of that height map. So the seed that is generating this, which at the moment is set to 0. And we're going to set this equal to rand I. Now, setting equal to rand I, I'm going to Control left click on rand I again. It returns a random unsigned integer, or 32-bit integer. Use remainder to obtain random value between but this basically gives you a really, really large random number, and that is going to be perfect for generating nearly infinite seeds. But the question is, how do we actually use this, right? Well, that's simple. We want to call this just after we clean the terrain map. So let's go and call this here. Let's go set up terrain height map. Now let's hit Control S and save. Now we've got the height map and we're randomizing it, so it's going to be different every single time. But that doesn't really help us, does it? It doesn't actually do anything right now. So let's go and do something. Let's create a new variable inside of our for x in terrain width and for y in terrain height here. So this new variable will go here and it will be called var. We're just going to call this random underscore height underscore value. We'll set this equal to an integer, if memory serves. Yeah, it's an integer. Actually, we won't even typeset this. We'll go through this as we go. So this is where it gets a bit complicated. I'm going to use a function here called, and this comes from our height map here. So let's first call our terrain height map. And we're going to use a function called dot get underscore noise 2D. Now we're going to pass through the x and the y coordinates that we're getting for the 4x and 4y here. And that's all we're going to do. So let's very quickly make a really large mistake and print out. I really don't suggest you do this because this can cause a lot of text overflow, and sometimes Godot can be a bit grumpy with this. So just kind of watch this. I wouldn't suggest following along. What I'm going to do here is I'm going to print out a string of the random height value. So if I hit Control S and save, pay attention to the output down here, and please don't crash Godot. And then I generate the terrain, and as you can see, 2,000, well, over 2,029 messages here, but you can see that it's generated a lot of really random numbers, and that's really nice. But there's an issue. As we keep scrolling through, there's two problems. One, these are all below 0 values. And two, some of them are actually negative values. Now, why is this important? Well, if I go back to our tile set, we're going to be using this height, and we're going to be plugging it into the x-axis on our tiles here. So we want to basically use this to select one of these 3 tiles. Now, if we look at the atlas coordinates, they never go below 0, and they never go over 2, just for these 3 tiles going from left to right. Now, this is an important thing that we'll have to talk about real quick, is this is only working based off of the x-axis of the atlas tiles. As we go in further in future videos, we will be expanding this to use both x and y, but just for basic terrain generation, we are going to use just the x-axis. But yes, we want to basically select a random tile using this noise map, or this terrain height map. Now, what does that mean? Well, if we go back to the output here and we look, we have some problems to fix. The first one is making sure that we're probably not going into the negatives, right? We don't really want negative numbers. So let's go and apply a fun little math function. Now that first math function we're going to apply is going to be called ABS, and we're going to wrap the terrain height map inside of ABS. Now I'm going to Control left click on ABS, and this returns the absolute value of a variant parameter x in an i.e. non-negative value. Now, we kind of need this to basically bump this into non-negatives. Now, if I go back to the terrain generator and I press play, we print that string out again, you'll see that all of the numbers that we're printing out are now all above 0. They're never going into negatives. That's really great. Do problem. They're all below 0. So with them being all below 0, they're still only ever going to set the coordinate here. So let's actually plug this in and we'll watch it kind of change. So where are we plugging this into? Well, when we're setting the cell here, we want to set the vector to I, or the atlas coordinate specifically. And we want, let's see what number changes here. We want this on the x-axis, so that's going to be the first 0 here. So we're going to want to plug in that random height value. So if I just press play and generate, you'll see it's still a green square. Even though we're generating a completely random value, it's still green, and that's because it's only below 0. It's always basically setting it to 0 because the tile set doesn't move in increments of decimals, it only moves in 0, 1, 2, so full integers. So now we have the absolute value. We're going to need to figure out a way of rounding this up. So before we round it up, let's first apply. So we're going to use times here. We're going to apply that terrain resolution multiplier. So let's plug that in here. So absolute of the terrain height map, x and y, times the terrain resolution multiplier. Let's press play and see what numbers we now get spat out. Oh, well, first you can see our map is no longer green. It's actually using our tiles, but there's a few issues. One, you've got these big grey squares, which are known as null tiles because they are invalid tiles. And 2, if I hit generate terrain again, you'll see that although we are going over 0 in some circumstances, sometimes we're actually going a bit over the actual, as you can see here, 5. 5 is a bit of an issue because we don't have 5 tiles, we only have 3, or in this case, because it's going to count from 0 to 1, 2 tiles. We have 3 tiles, I'll just leave it at that. But that means we now need to do one more thing to make sure that this functions well. So just after absolute and just before terrain height map, we're going to want to use round I, and we'll wrap everything here in another parentheses, like so. So what you should end up with is absolute parentheses round I parentheses terrain height map dot get noise 2D using our x and y coordinates times the resolution multiplier in parentheses. So why are we timesing the resolution multiplier? Why is that a thing? Well, we need to times the numbers that we are currently using by 10 to get them out of the 0 numbers, right? So let's press play and see what happens. Well, same thing. But as you can see, we are now getting full whole numbers, which is really, really nice. We're getting whole numbers ranging from 0 to 5 by the look of it. Now, that works well, but we're going to want to make sure this doesn't have dead tiles. So to make sure that this doesn't have dead tiles, what I'm going to do here is under the generate terrain function, I'm going to create a new variable at the very top here. This new variable will be for the terrain underscore tile underscore map underscore, actually no, that's going to be too much. We'll go tile underscore map underscore tile underscore count, and we just need to grab the tile map data count so we can basically see how many tiles we currently have. So first we're going to want to call the tile map, oh wait, this will be an integer, and then we want to say equals the tile set, which is part of the tile map layer. So tile set dot get underscore source, so we're going to need to get the source of this tile set, which in this case is source 0, so we know what source we're on. So source 0 dot get underscore tiles count. Now this is going to return a count of how many tiles are actually in our tile set. Now I'm creating this variable just so I don't have to type out this a lot, but this will be fine for now. So let's go and fix this. One, we will do this above the print statement, and two, what we're going to do here is an if statement. We're going to do a quick if check. We're going to go if the random height value is, we'll go greater than or equal to, no, we'll just go greater than the tile map tile count. Then we want to set that random tile, or that random height value, equal to the tile map tile count. Now, what that's going to basically do is never go over the amount of tiles we have. Now, there is an issue here, and this is how indexing kind of works. When this is counting, it's counting from 1, 2, 3. So 1, 2, 3, right? We have 3 tiles, so it's going to say 3 tiles. But with how indexing works in this, we need to make sure that it never goes over 2, because that's the maximum amount of coordinates we have. So to do that, we're simply just going to go up to our variable here, and we're going to write -1, and that's it. That's all we need to do. Now, if I press play, what should happen here is, 1, it'll generate a full tile map, and if I scroll through all of our numbers here, you'll see that none of them ever go over 2, but it is, 0, 1, 2. Now, this is more or less how you create a really, really, really simple tile map generator or terrain generator. Now, what I want to show you is how kind of unique this can get, because if I full screen this, what we have here is what looks like, we have beaches, little forests, and lakes. Now that's really, really cool, but that's not nearly as deep as we want to go with it. So let's close this and let's make some changes. Let's make some modifications. First thing we're going to modify is the frequency of the terrain height map. this is where all of the data for how our terrain looks is going to be. So first, let's mess with the frequency. Let's zoom this out a lot, so it's, a little bit more fuzzy. And generate, and you can see now we're getting these kind of long spaghetti islands, literal spaghetti basically, a lot more lakes and nearly oceans forming. Let's zoom this out even more. This is where it starts to get a bit weird looking. Now we're basically just getting whatever you would call that. But on the flip side, if we zoom this in more and we press play and generate, we're now getting larger lands and larger oceans. That's a bit weird, right? Larger and larger. Well, that's kind of like, the frequency is kind of the resolution of sorts of this map, where it's like really, really zoomed in so you can see more. So as you can see, I can just kind of make fun little patterns as we go through with this. But that's just frequency modification. What else can we modify? Well, we can modify the noise type. So let's go from simplex smooth to cellular. Now let's zoom this out a little bit, press play, and a weird thing will happen. It's blue. Why is it blue? Well, this is where the multiplier or resolution multiplier that I have kind of comes in. If I change this from 10 to 1 and I press play, you'll see that we're still getting tiles, but we're not getting everything. It's a little bit odd with how this kind of functions. Cellular noise can be a bit awkward for this type of generation. So let's change to cubic. We'll leave it at a resolution of 1 as well and see what happens. Well, it's green. Okay, let's knock this up to a resolution of 10. Generate the terrain, and there you go. We're now getting different terrain again. Let's reset the frequency, press play, and generate the terrain. And it's now very zoomed in, but it's more land-like, which is really, really cool. Next thing we can mess with is the fractal noise type. So we can change the type from FBM to, let's say, ping pong. Ping pong's always really interesting to do. We can change the amount of octaves it has. And as you'll see with me adjusting this picture, the actual picture up here changes. So let's take this all the way down to 1 octave. And you end up with basically just bands, which is, once again, really fascinating. Let's zoom this out. Now you see all of the spaghetti. Hit generate terrain. And we now have these really, really long lines of spaghetti. Apparently spaghetti's become my favorite thing in this video. Don't know why. So let's bump the octaves up back to 5. And then let's bump up the lacnarity. I don't know how to say that word. Frequency multiplier between substance octaves. Increasing this value results in higher octaves producing noise with finer details and rougher appearance. Nice little tooltip that. So let's bump this up a little bit. And as you can see, it's like an overlay, so that you've got like another layer of noise over the noise. Let's bump that up. Let's bump up the gain a little bit. Let's even pull in the frequency a little bit, and let's see what this generates. More kind of rough spaghetti islands. Interesting. Well, let's change from cubic back to simpler. Let's go Perlin. Yeah, let's go Perlin, and let's zoom this in more. Hit generate terrain, and it's a little bit different, but it's not as different as I'd like it. So let's change the weighted strength. The weighted strength basically makes colors lighter and darker, or in this case makes the blacks more black. So now we're ending up with some islands and more oceans. Interesting, we could use that for a lot of different things. But this is a really, really long, complicated way of saying this is a really interesting little thing that we will be building upon a lot. Now let's do one last thing and bump up the terrain width and terrain height and see how this reacts. Generates it instantly. And now we have a larger window with a lot more terrain generating. Nice. Now, there's plenty of other things we can actually do with this, and I'll be honest with you, this is as much as I'm wanting to show right now, because the next few videos are going to be a lot more in-depth. We're going to be generating mountains, forests, like actual tree placement, and then we'll be going into some automatic like NPCs and AI that like to run around and do their own thing and create basically a little simulation game just from this really, really simple generator. Now, the other thing I want to generate, of course, I want to add things like humidity for jungles, weather, like, temperature, so hot, cold for deserts and ice biomes and things like that, and actually kind of do biome generation as well. But I want to do this in a really kind of fun way. But for now, that is all we're going to do. So if you have any questions, make sure you leave a comment, or come down to the Discord. A link is in the description. If you really want to see how far we can take this terrain generator and what we can do with it, make sure to subscribe and hit that bell for notifications, because I will be uploading those videos as we go. But yeah, that's pretty much it. Thank you for watching. I hope you've had a good day and you are having a great game dev journey, and I will see you in the next one.